A user drops a confidential audio clip into a web page. The page transcribes it, and the clip never travels to your server. That is the useful promise of WebGPU AI. WebGPU exposes modern GPU compute to web applications. Transformers.js can load compatible models through ONNX Runtime Web and select WebGPU as the execution device. Hugging Face documents examples for text embeddings, whisper speech recognition, and image classification. The mechanism has 4 stages. The browser downloads model files. JavaScript prepares inputs. The runtime dispatches tensor operations to WebGPU. The result returns to the page. No inference API is required for that path. Use case 1 is private transcription. The page loads a small whisper model, decodes an audio file locally, and displays text. The application can work offline after required assets are cached. The proof is network inspection. Audio bytes do not leave the browser during inference. But startup matters. A model can be tens or hundreds of megabytes. The first visit may spend longer downloading weights than a cloud API would spend answering. Show progress, support cancellation, cache versioned assets, and do not pretend a blank screen is initialization elegance. Use case 2 is client-side embeddings. A Node application can embed local passages for semantic search. The query and notes remain on the device, and results appear without a server round trip. The limitation is memory. Model weights, intermediate tensors, document vectors, and the rest of the application compete inside the browser. Mobile devices may terminate a tab that desktop testing considered perfectly healthy. Use case 3 is image classification. The browser can classify or filter an image before upload. An application might detect document type locally, then ask the user whether the file should be sent. Do not treat the classification as a security boundary unless it has been tested for that purpose. A client controls its own browser and can bypass local logic. Compatibility is the next challenge. WebGPU support depends on browser, operating system, hardware, and drivers. Provide a feature check and a fallback. WebAssembly or a server route may be slower but more broadly available. Benchmark real devices. Measure model download, initialization, first inference, warm inference, memory, battery, and result quality. Test integrated graphics, discrete GPUs, mobile devices, private browsing, storage eviction, and background tabs. Quantization can reduce model size and improve speed, but quality may fall. Compare the same frozen examples rather than assuming smaller is free. Move inference off the main UI thread. A web worker can load the model, receive typed requests, and return progress and results while the interface remains responsive. Cancel stale work when the user changes input version the worker, runtime, and waits together, so a cached old model cannot silently meet new application code. Cache carefully. Use immutable model URLs with hashes, check available storage, and provide a remove downloaded model control. The user should know whether offline AI occupies 50 megabytes or 2 gigabytes. On metered connections, ask before the first large download. For long inputs, stream or window them according to the model's real contract. An audio recognizer may process overlapping segments. An embedding model may batch passages. Do not send an entire novel into a browser tensor and call the resulting tab crash edge inference. Privacy needs precise language. Browser inference keeps the computation on the client for that operation. It does not prove the page has no analytics, cloud backup, remote fonts, error reporting, or later upload. Use the browser network panel and a documented data flow map. Give users an offline mode that actually blocks network access if privacy is the promise. Security has another side. The model is delivered to the client. Users can inspect downloaded weights and application code. Do not put a proprietary model in a public web bundle and expect JavaScript obfuscation to become a vault. Also treat model files as supply chain artifacts. Pin versions, verify hashes, use content security policy, restrict remote origins, and review runtime updates. WebGPU works best for bounded tasks with manageable models, embeddings, classification, transcription, background removal, feature extraction, and smaller generative workloads. It is a weaker fit for enormous models, long contexts, high concurrency on one device, or workloads requiring protected server data and tools. Build a hybrid router. If WebGPU is available, the model is cached, the task is supported, and local policy is preferred. Run on the client. If the device lacks support or the task exceeds local limits, ask before using a server route when data sensitivity matters. Return the same typed result from both paths so the interface does not care which engine ran. Then show the route in diagnostics, local WebGPU, local WebAssembly, or cloud. Treat quality as part of routing too. A tiny local model may be private and fast but unsuitable for the requested language or audio quality. Maintain a small device-side qualification set on first setup, run representative inputs, record speed and correctness, and enable only the tasks that clear the product threshold. For updates, download new weights to a separate cache key, verify the checksum, warm the model, and switch only after a smoke test. Keep the previous version until the new one proves stable. If initialization fails, fall back explicitly and preserve the user's data routing choice. Accessibility also matters. Announce download progress to screen readers, keep the interface responsive during inference, and provide a non-GPU path. Local AI should not make the page unusable for the people it was meant to protect. Log performance categories without logging private inputs. Device class, selected route, initialization time, inference time, failure code, and fallback. Those signals improve routing while keeping user content outside analytics. WebGPU does not kill the inference server. It creates a new place to run the parts of AI that benefit from low latency, offline use, and local data. The winning architecture sends less by default, measures the device honestly, and falls back without turning privacy into a surprise.